Now that we've learned how to classify triangles, we're going to use some properties of triangles to find missing angles. So first let's look at isosceles triangles. And an isosceles triangle has some special kind of parts. In this one, we see that we have two sides that are congruent, so it is isosceles. The angle between those two congruent sides is called the vertex. The angles opposite those two congruent sides, angle A and angle C, are called the base angles. And heads up, I need you to write this down and memorize it. This is the base angles theorem. It says base angles are always congruent in an isosceles triangle. And then what we call the two congruent sides, in this example AB and BC, are the legs of the isosceles triangle, and we call the third side, AC, the base. So we will be using this terminology, but the thing I really want you to know is that all base angles of isosceles triangles are congruent. Okay, when we're talking about equilateral triangles, remember equilateral means that all sides are congruent. Equiangular means that all angles are congruent. And I think we have seen that an equilateral triangle is always also an equiangular triangle. Now, when you are talking about, in general, any polygon, and it is both equilateral and equiangular, whether it's a triangle or any other kind of polygon, it is called a regular polygon. So an equilateral triangle and an equiangular triangle is a regular triangle. Okay, this is, I think, already written in your notes, but this is the triangle sum theorem. So again, you need to memorize this if you don't already know it. And that is the sum of the interior angles of a triangle must add up to 180. So no matter how big or how small that triangle is, the sum of the interior angles has to equal 180. Okay, so now let's use some of this stuff. Here we're looking at this triangle ACT, and we see, because of the markings, that it is an equilateral triangle. Well, we know that an equilateral triangle is also an equiangular triangle. It must be. So therefore, all of the angles have to be the same thing. That means every single one of those angles has to equal 60 degrees, because 60 times 3 is 180. Okay? Now, if I'm going too fast, just pause. Take the notes you need, then restart. In this triangle, we can see, because it has two congruent sides, that it's an isosceles triangle. And we know that base angles are congruent in isosceles triangles. So if we gave angles P and D a variable, they have to be the same because they're congruent. Let's call them X. Then we know by the triangle sum theorem that all three of those angles in that triangle, 60 and X, if I add them up, I have to get 180. And then if I solve this, 60 plus 2x equals 180, I would get x equals 60. So both of those angles are 60 degrees. Now you could have been, or you might have, looked at this immediately and said, hey, the base angles are congruent, and if the vertex is 60, the base angles have to be 60. That could have popped at you instead of having to do the math. All right, let's look at this. This DOG triangle is also an isosceles triangle, so I know that the base angles have to be congruent. So if D is 48, then C also has to be, G also has to be 48. And to find the vertex, angle O, I'm going to use the triangle sum theorem, which says that if I give O a variable, let's say it's x, if I add up all the degrees of all three of those angles, x plus 48 has to equal 180. If I solve that equation, I'm going to get that x equals 84. Now, you may have noticed that I am writing less and less work on solving my equations, because some of this I'm hoping you're doing in your head. Okay. Now, let's look at this. We've got two triangles stuck together here, and you may have to modify your note packet. We had some where we didn't have all four of these angles written down, or we had them written as just angle A. So fix your note packet if you need to look like my screen. And here's what I'm going to recommend when you get something like this in your practice. I want you to draw the triangles separately on your paper. Okay, so the first thing I'm going to do is I'm going to just draw triangle TAO. And I know by looking at it that it is an isosceles triangle because two legs are congruent. And I know that the base angles of an isosceles triangle are congruent. So I'm going to give them the value of x. They would both equal the same thing. And then by the triangle sum theorem, I know that if I add all three of those angles up, x plus 50, has to give me 180. If I solve that, I get that angle TAO is 65 degrees. So I think I put that in my thing. Yeah. And angle T has to be 65 degrees. All right, so now let's look at our other triangle. So again, I'm going to draw this on my paper without the first triangle, but I'm going to keep that degrees of angle TAO because I need to find angle OAC. Now, I notice that angle TAO and angle OAC form a linear pair. And remember that a linear pair is this, where you have a line. Why is that not working? Here we go. We have an angle whose non-shared sides form a straight line. And we also know that a linear pair is always, always, always supplementary. That's a definition of a linear pair. And therefore, I can say that if I give that angle OAC a value of x, I can say that those two angles added together have to give me equal 180 because that's the definition of supplementary. And I'm going to solve for x and get that the measure of angle OAC is 115 degrees. Now, let's erase everything but my 115 degrees and the triangle that I'm looking at. Well, right away, I can see this is an isosceles triangle. Again, and I know that base angles are congruent. So by the triangle, if I give those base angles each a variable of x, by the triangle sum theorem, I know that if I add x plus 115, it has to equal 180. And when I solve that, I'm going to get that x equals 32.5 degrees. So angle C has to equal 32.5 degrees. Now, I want you to look at where we started. We started with two triangles with hardly any information, and we drew them separately and only wrote down the information that we needed. That's a very powerful tool when you're solving these kind of problems. Don't try to solve them with all the information there. Just write down what you need. Okay, let's try this one. All right, I've got two triangles, so I'm going to break these apart. I'm going to ignore that small one, and I'm just going to look at this big one, triangle BAD, and I see that this is an equilateral triangle. Well, I know that all equilateral triangles are also equiangular. Therefore, all of those angles must equal 60 degrees. All right, so now that I know that, let's look at my other triangle. I know that this angle, because of the marking, is 90 degrees. Well, part of that angle is 60 degrees. So if I take 90 minus 60, I get that this little part of my small triangle is 30 degrees. Now, let's only write down my small triangle with the 30 degrees. Well, I'm looking at this, and I can see that this small triangle is an isosceles triangle. And I know that isosceles triangle, the base angles are congruent. So if angle D is 30 degrees, I know that angle B has to be 30 degrees as well. Then, by the triangle sum theorem, I know that all three of those angles, if I give the other angle an x, if I add them all together, 30 plus x has to equal 180. So when I solve that, I'm going to get that my angle C is 120, I said 180, I meant 120 degrees. Okay, so now look at where we ended up. And look at where we started. I think I erased angle C. Sorry. See if I can get that back on there. There we go. And look at where we started. So only write down what you need on your paper. Don't try to do this stuff in your head. It's way too hard. Okay, now you know how to do this. I want you to, on this next one, I want you to pause your video and try to solve this on your own. So pause your video now and then come back and I'll walk you through it. Okay, now that you've had an opportunity to solve this, hopefully you erased your small triangle and said, hey, this is an equilateral triangle. Therefore, I know it's equiangular. Therefore, I know all of those degrees are 60, just like in the last one that we did. And then I'm going to look at my smaller triangle and I'm going to say, hey, that whole great big angle is 90. If I subtract 60 from it, I'm going to get the value of x, which is 30 degrees. Then, hopefully, you said by the triangle sum theorem, I know that x plus y plus, so x is 30, 30 plus y plus 90 has to equal 180, therefore y equals 60 degrees. All right, again, you guys, anytime you're watching a video, because I'm going to go pretty fast through it, if you need to pause me and rewind me and listen to me again, do it. All right, our very last one is we have two triangles. It kind of looks like an hourglass. So what I want to do is I want to work with the triangle that has information on it, which is the bottom one. So I'm just going to erase the top one for a minute. And I'm going to say, this is an isosceles triangle. Therefore, I know that the base angles are congruent. So if one base angle is 55, the other base angle has to be 55. Now, I also know by the base angles theorem that if I add up x plus 55 plus 55, it has to equal 180. Therefore, I'm going to solve for x and get that x equals 70 degrees. So I found my first variable. Now let's look at that second triangle. Well, I know these two angles formed there are vertical angles, and the vertical angle congruence theorem says all vertical angles are congruent. So I know the vertex of that small triangle is also 70 degrees. So now let's ignore our big triangle and just look at that little one. Well, look, that is also an isosceles triangle. Therefore, the base angles on it are also 70 degrees. So if one of my base angles is y, the other has to be y as well. Then I know by the base angle, or by the triangle sum theorem, that y plus 70 has to give me 180 degrees. And when I would solve for that, I would get that y equals 55 degrees. All right. I think you have enough information and we've done enough examples that you can do your practice now.